Welcome to Manifest Maths. In this session we're going to look at coordinate geometry, finding the equation of parallel and perpendicular lines. My recommendation is, if you haven't looked at the video on finding the equation of a line, I suggest you go and look at that. Typical question for us to look at. We might have three coordinates A, B and C. We might be told the line through A is perpendicular to the line BC and intersects BC at the point D. So for a question like this, you need to be able to understand how you form a perpendicular line, the equation of a perpendicular line. That's what we're going to look at today. So we're going to jump straight in with the question, but before we start, I'm just going to show you the relationship between perpendicular gradients and parallel gradients. So let's say we have a straight line which has, for example, a gradient of say 3/4. So what that means is, for every one across on the graph we go 3/4 up. So it'll be a steepness synonymous with that diagram. If you want to find the perpendicular gradient, the method that we would use is we would find the reciprocal. We call the perpendicular gradient M2. We find the reciprocal of the fraction, so will become 4/3. And we change it from positive to negative. So if a gradient of one line is 3/4, then its perpendicular gradient will be minus 4/3. Formally, what we could say is that M1 times by M2 will equal minus 1. So for example, 3/4 times by minus 4/3. That will give us 3 times by minus 4, which is minus 12. And 4 times by 3, which is 12, which gives us a gradient of minus 1. Okay, so that's predominantly the relationship that we're going to use in today's session. So we've got 2 points A and B. We have coordinates minus 2, 10, and 12, 3. The line L is perpendicular to AB and intersects the y-axis at the point 0, minus 1. The line AB and L intersect at the point D. So there's a lot of information that's been given in this question. So step one is to use the fact that we know that L is perpendicular to AB. So first of all, we've got to find the gradient of AB. We're going to use, this is our x1 and y1, and this is our x2 and our y2. And our gradient is going to be equal to y1 minus y2 over x1 minus x2, which in this case gives us 10 minus 3 over minus 2 minus 12, which gives us 7 over minus 14, which is the same as minus a half. Now, that's the gradient of AB. We could just summarize this on a set of axes, so x and y. If I was to plot minus 2 and 10, that would be approximately here, that would be point A. Point B would be at 12, 3. And we can see that we've got quite a shallow line coming down. For every one across, we go half down, so it looks like that's a realistic gradient. Okay. Now, we need to find the equation of L, and L is perpendicular to AB. So our initial gradient, M1, was minus a half. So our perpendicular gradient, which we're going to call M2, will be equal to the negative reciprocal of that. So we flip the fraction upside down, it becomes 2/1. We change it from a negative to a positive. 2 divided by 1 is 2, so our gradient is equal to 2. This is our perpendicular gradient. So the gradient of L is equal to 2. Then we use the equation of a straight line. So y minus y1 equals m brackets x minus x1. And we're told that the line L intersects the y-axis at this point, see? So this can become our x1 and our y1 for the equation. We could plot that on our graph. So 0 across and minus 1 down. That would be somewhere here. Okay, so now given that this line L has got a gradient of 2, it's going to look something like this. And this is going to be our line L. So we substitute our values in. So y minus our y1, which is minus 1, equals m, our gradient, which is 2, brackets x minus 0. That gives us y plus 1 equals 2x, 2 divided by 0 is 0. So y equals 2x minus 1, and that's the equation of L. And you can see that if we were to plot this using the gradient intercept method, this would be our intercept of minus 1, and it looks like it's got a gradient of, for every one across, we go 2 up. Okay, so that's the answer for part 1. Now part 2, we need to show that D as the coordinates 4, 7. Now there's a few ways of doing this. We're trying to locate where the lines intersect here, which is D. The best way to do this is probably to solve the two equations potentially as simultaneous equations, okay? Or alternatively, another method we could use is to substitute the values 4, 7 into the two respective equations. Okay, I'm going to opt for the simultaneous equation method. So we've got the equation of L. We might want to find the equation of AB. Now we've got all the ingredients we need for that. So we can use y minus y1 equals m brackets x minus x1. And we can use either of these two coordinates to substitute in. So I'm going to use the first ones. So y minus 10 equals, now our gradient for the first line was minus a half. So minus 1 over 2. Brackets x minus 2. That gives us y minus 10 equals minus half x. The x minus 2 becomes plus 2. And if we times plus 2 by minus a half, that gives us minus 1. Then we can multiply everything by 2 to get rid of this 2 at the bottom. So 2y minus 20 equals minus x minus 2. And then we can bring the x elements over to the left hand side. So 2y plus x equals 18. That's our first equation, our second equation, sorry. We've got our other one here, which is this one. Now, if you see that we've made 2y plus x on the left hand side, so we can do that the same thing here. So if we bring the 2x over, it becomes y minus 2x equals minus 1. And this is our second simultaneous equation that we're going to use. So if you put the second equation underneath, and these are the simultaneous equations that we're going to solve. It might be desirable to multiply the top equation by 2 to get the y coefficients the same. That gives us 2y minus 4x equals minus 2. Then if we subtract the two equations, so 2y minus 2y eliminates the y's, x minus 4x gives us 5x, and 18 minus 2 gives us 20. And then we divide 20 by 5. That will give us our x value, and we see that x is equal to 4. Just like we needed here. Then to solve for our y, we can use either of the equations. I would use this one directly. So y equals 2x minus 1. So y will be equal to 2 times by 4 minus 1, which gives us 8 minus 1. So 1, by the way. And y is equal to 7. Okay, and we've proved that the coordinates of D are 4, 7. Okay, this is one for you to try then, so pause the video and give it a go. So we've got 3 points A, B and C, with this one being our C value. The line L passes through C and is perpendicular to AB. So the first step is to find the gradient of AB. Label these x1, y1, x2, y2. So the gradient of AB, our gradient, using m as a gradient, is going to be equal to our y1, which is 3 minus 0, over minus 7 minus 2. That's going to give us 3 over minus 9, which gives us minus 1/3. We need the perpendicular gradient, okay, because L is perpendicular to it. So the gradient of L will be equal to the negative reciprocal of this. We flip the fraction upside down, it becomes 3 over 1, and it gets changed to a positive. So our gradient is equal to 3. Okay? Then, finally, to find the equation of L, we're going to do y minus y1 equals m brackets x minus x1, using our C point for that equation. So this is our x1 and our y1, which gives us y minus 5 equals 3 brackets x minus 3. Gives us y minus 5 equals 3x. Minus makes a plus. 3 times by 3 is plus 9. So y equals 3x. If I bring that plus 5 over, I will add 5 on to 19, which is 3x plus 14. Now at this point, it might be desirable just to check and see if that makes sense. So we've got x and y. Plot our points. So A was minus 7, 3. So let's just put that here. And minus 7, 3. B was 2, 0. So that's going to be around here. 2 across and 0 up. And then if we join those up, we see that AB has got a negative gradient, which we had. And for every 1 across, it looks like we go about a third down. If I was then to plot point C, that would be at minus 3 and then up to 5, so somewhere about here. Now if I was to plot this line L, this is our gradient, so our gradient is 3 and our intercept is 14. And that would be, you know, somewhere, if I was to extend this line up, somewhere up here. And if I was to join through C to there, we see that we've got a steep gradient. So for every 1 across, you go 3 up. So it seems about right. Obviously, the next step could be to find the point of intersection. That's what's going to be the theme of the next video. Okay? Right, 3 questions for you to try. So pause the video, give these a go, and then I'll go through the solutions on the next few slides. Okay, so question 1. Hopefully you've had a chance to try this question. We've got A and B, we've got 2 points. So let's label this x1, y1, x2, and y2. Point C is the midpoint of AB. Okay, and the line L is perpendicular to the perpendicular bisector of AB. So for this question, I'm going to start off by plotting our points A, B. So our point A is minus 2 and 7. So that's going to be roughly there. And then 6, 13. So 6 across and 13 up. So point B is up here somewhere. If I was to join those two, you see we've got a positive gradient. Now C is the midpoint of these, so it's going to be roughly in this position here. Okay. Now the question's asking us to find the equation L eventually, and it's a perpendicular bisector. So if you think back to GCSE maths, that's the line that's going to be coming down through that midpoint. So this is the scenario that we've got going on with this question. Part A is asking you to find the gradient of AB anyway. So part 1, our gradient, or our m of AB, is equal to y1 minus y2, so 7 minus 13 over x1 minus x2, which is minus 2 minus 6. That gives us minus 6 over minus 8, which gives us 3/4 as our gradient. Okay. Now for part 2, we've got a few things to do. Step 1 would be to find the perpendicular gradient, because the line is the perpendicular bisector. So if our gradient of AB is equal to 3/4, our gradient of L, the perpendicular bisector, is going to be 4 over 3, but changed to a minus 4 over 3. We also need our midpoint, which is point C. So we need to find the midpoint of AB. And that would be equal to the average of our x coordinates. So minus 2 plus 6 divided by 2. And 7 plus 13 divided by 2. Minus 2 out of 6 is 4, and 4 divided by 2 is 2. 7 out of 13 is 20, divided by 2 is 10. So our point C is 2 across and 10 up. Okay, so we've got 210. And the final step is to use the equation of a straight line, which is y minus y1 equals m brackets x minus x1, using our c values of our x1 and our y1. So y minus 10 equals minus 4 over 3 x minus 2. I would multiply throughout by 3, which gives you 3y minus 30 equals minus 4 brackets x minus 2. And then 3y minus 30 is equal to minus 4x plus 8. Now, bearing in mind for the next part of the question, you might have to solve simultaneous equations perhaps, so it might be an idea to bring the x's over. So keep the 3y there, change the minus 4x to plus 4x, and then to add 30 onto 8, which gives you 38. And this is probably the most desirable form for that equation. Right, the second question. So the line L1 passes through the points A, B. You've got to find the equation of L1 first. Okay, so we're going to use the equation of a line. So y minus y1 equals m brackets x minus x1. We need the gradient first. So the gradient is going to be equal to our change in y's over our change in x. So let's label x1 y x1 y1 and x2 y2. So y1 minus y2 is going to be 5 minus 1 over 0 minus 3. So that becomes 6 over minus 3, which is equal to minus 2. So the equation of line L1 is going to be y minus, now it might be desirable to use your first set of coordinates, A, with our y1 being 5. Our gradient is minus 2. And we have x minus 0. So y minus 5 equals minus 2x. Bring the minus 2x over, so y plus 2x equals 5. Now, part B. The line L2 is perpendicular to L1 and passes through the origin. So remember, our origin of the coordinates 0, 0. Okay? And the line L1 is perpendicular, L2 is perpendicular to L1. So our gradient of L1 was equal to minus 2. So our gradient of L2 will be equal to 1 over 2. So remember that if you've got minus 2, that can be written as minus 2 over 1. So if you flip the fractions down, it becomes half, and then from minus to positive, it's a positive quantity. Then to use the equation of a straight line, so y minus y1 equals m brackets x minus x1. Now, for the origin, y1 and x1 are 0, so it's y minus 0 equals half brackets x minus 0. So we end up with the equation y equals half x. Right, next question. So the line L1 passes through the points A and B. The line L2 is the equation 2y plus x equals 25 and intersects L1 at the point C. L2 also intersects the x-axis at point D. Show that the equation of the line L1 is y equals 2x plus 5. So for the first part of the question, much of this information is irrelevant. We're trying to find the equation of L1. So we've got our equation of a straight line, which is y minus y1 equals m brackets x minus x1. We can use A as our x1 and y1, and B as our x2 and y2. Okay, and we're going to substitute these values in to find the gradient of L1. So the gradient of L1 is going to be equal to 3 minus 9 over minus 1 minus 2, which gives us minus 6 over minus 3, which which gives us a gradient of 2. Substitute our gradient and a pair of the set of the coordinates into our equation of a straight line. So y minus 3 equals 2 brackets x minus 1. Y minus 3 equals 2x minus 1 gives us plus 1 times by 2 is plus 2. And then make y the subject, so y equals 2x minus 3 add onto 5 gives us 2 gives us plus 5. So we've shown the first part. Now it might be a good idea to plot that, okay, on the next part before we try the next part of the question. Our intercept is 5, so let's put that there. And our gradient's 2, so every 1 across we go 2 up. So the line will look like something like this. Only it should be straight, not wonky like mine. Right, and on to part B. Now, before we do part B, let's just read the rest of the question. The line L2 has an equation 2y plus x equals 25 and intersects L1 at point C. L2 also intersects the y-axis at point D. So, first step is to find the coordinates of point D. Now, the x-axis is obviously the axis going across the bottom. So, the situation we've got going on here is we have a perpendicular line coming down through this and it intersects the x-axis at D. Okay? Now, the important thing to understand is that at point D, okay, the x-coordinate will be a positive number, but the y-coordinate will be 0. So we could call that, let's call the x-coordinate A, that's not a 9, that's an A. And our y-coordinate will be 0, so A, 0. Now we're already told the equation of L1. Okay, now to find the coordinates of point D, we need to use the equation L2, which we're also given. Now L2 is 2y plus x equals 25. Now we already know that y has got to be 0. So if we substitute 0 into this, we end up with 2 times by 0 plus x equals 25. So we end up with x as being equal to 25. So the coordinates of D are 25, 0. You can see how badly drawn my diagram is here. We could label that on here, so this would be 25. Now for part 2, we need to show that the line L1 and L2 are perpendicular. Now there's a few ways of doing this. Okay, we know the gradient of L1 was 2. We need to just show that the gradient of L2 is therefore the negative reciprocal of this, which is minus half. The best way to do this is probably to think about the equation 2y plus x equals 25, and maybe to make y the subject. So the reason the gradient was 2 here is because y was equal to 2x plus 5. So if we try and make y the subject of this, we have 2y equals, I bring that x over as minus x plus 25. And if I divide everything by 2, I end up with y equals minus x over 2 plus 12.5. And then you can see that the gradient of this line is equal to minus a half. So the gradient of L2 is equal to minus a half, or x divided by 2, which is the same as half x. Okay, let's revisit the first question on the first slide of the PowerPoint. And there's a lot going on with this question. We've got 3 points given to us, A, B and C. Ultimately, the goal is to find the equation of AD. Okay, now we're given lots of information here. The line through A, perpendicular to the line BC, intersects BC at the point D. So the best way to start this question is probably to think about it in terms of a diagram. So if I just go back for a second and we think about what the diagram is going to look like. I'm just going to sketch it up here. X, Y. The points A have the coordinates 8, 4. Point B have the coordinates 6, -5. C is 3, 7. Let's label that C and that B. And we are told that the line through A, perpendicular to the line BC, intersects BC at point D. So if we join BC together and then consider the perpendicular line through A, through that, okay, that point here will be point D, okay? Now we need to find the equation of AD, so the line joining A to this point D here. Now we know the gradient of that is perpendicular to the gradient of C at BC. So step one for this question would be to find the gradient of BC. Okay, so this is our B and this is our C, so we call that x1, y1 and x2, y2. We're going to have -5 minus 7 over 6 minus 3, which gives us -12 over over +3, which gives us a gradient of -4. So it's a steep negative line. You can see it's very steep, so for every one across we go 4 down. Now we need our gradient of AD, which is perpendicular. So we're going to take the negative reciprocal of this, so it's going to become 1 over 4. And then next step is to use the equation of a straight line, so y minus y1 equals m brackets x minus x1. We can use our A coordinates for that. So we have y minus 4 equals 1/4 x minus 8, multiplied throughout by 4, so 4y minus 16 equals x minus 8. Bring the letters to the left, so 4y minus x equals, add 16 onto minus 8, which gives us 8. Okay, now just to see what this would look like, I'm going to make y the subject, use the gradient and intercept method. So 4y would be equal to x minus 8, plus 8, sorry. And y would be equal to x over 4 plus 2. So what you can actually see is I haven't drawn the diagram particularly well because this has got a positive gradient. Okay, so it should probably be more something like this, and the gradient intercept there would be 2. And for every 1 across, I only go 1/4 up. This is far too steep. So essentially, if you look there, my angle is not 90 degrees. To make it more like 90 degrees, the line will be a bit flatter. Okay. Next step could be to find point D and to solve simultaneous equations, and that's going to be the next topic, the topic of the next video. Okay.